All right. So here's what we want to do next. I tried to follow this notebook which talks about building your first AI agent, where we install the required dependencies and we restart the kernel. Then we pick up the endpoint name here. This endpoint is getting picked up, Metalama 3, right? And then we have this bunch of code which is having bunch of functions. So I need to, basically the idea is to understand what is all this. So I would want Claude to help me dissect this code line by line and help me walk through this or trace this code. So what I'll do is I'll copy this and I'll get to Claude and say, all right, I'd need your help to develop deeper understanding of the okay, I would say of the below code. Establish the need of the code, impact the execution of the code will make. Start tracing line by line. Produce a small piece at a time. Wait for me to understand. Ask further questions. Or ask you to proceed if everything looks good. Okay, and let me just, I need the code also, so I'll fetch the code. So I'll go here and then say copy cell and I'll say okay, and I'll pass on the code. So it explains. This code creates an AI agent that can think and act. Unlike a simple chatbot that only generates text, this agent can receive a question from you, decide if it needs to run Python code to answer, actually execute that code, give you the results. So receive a question, decide if it needs to run the Python code to answer, actually go ahead and execute that code, and whatever is the result returned, it gives you that. Yeah, so that we have seen a bit. So first we need few imports. So JSON, this is to handle data formatting between the AI and tools. Okay. ML flow logs and tracks AI conversations or debugging. Okay. Workspace client connects to Databricks services. Okay. UC function toolkit, Databricks function client gives the AI access to Python execution tools. Okay. Okay, so impact these imports, set up the foundation. Without them, your agent couldn't connect to models or use tools. Okay, looks good. Let's proceed. Okay. So meanwhile, let me show up. So here we are. So these are the imports. And we'll come back. And here we have seen JSON, MLflow, logging and tracking of AI conversations, workspace client connecting to Databricks services, UC function toolkit. Databricks function client gives the AI access to Python execution tools. Okay. Okay. That will help set up. Next is MLflow OpenAI Autolog. Let me go there. So MLflow OpenAI Autolog. It turns on automatic recording of every conversation with your AI agent. Okay. Creates detailed traces showing what the AI thought, what tools it used, and what results it got. Like having a black box recorder for your AI agent. Yeah, that's pretty good. So I can basically do some conversation and I can read from this. Somewhere it's going to store, right? So I want to ask that question that if I execute this, where does it store? So if it is automatically logging, it must be storing somewhere, right? So let's highlight this piece of code and let's come to AI. Okay, now I'm looking at this piece of code. You mentioned that creates that it creates. So for the ongoing notebook, how can I read the traces captured through this piece of code? And let me give this snapshot. Let me copy. I'll put it here. Hmm. So it says when you run your agent code like the square root example, the traces appear automatically below your cell output. You've already seen this. Yeah. So we have seen that that screen, correct? I'm talking about this. So we have seen this MLflow trace UI, right? Okay. So this is what it meant. Detailed trace. So this is the detailed trace. So I was thinking if there is an automated way. So this appears more like UI. Appears more like UI. So what we do the other way? It's saying in the left bar, click experiments, find your current notebook experiment, click on any. Okay, let's go to the notebook. So it's asking us to go to experiments, find your current notebook, which is this one. Click on any run to see detailed traces. So here we have experiments and I think this entry is called as a run. And it's saying to click this, is it? Okay. So there are two runs here, which is mentioned. There is a response which has a lot of information. So let me capture this information. Okay, so this is something I tried. I'll keep it again like this. Okay, so I'll just take this. Okay, so I'll take this, come to my AI screen and paste this and say, I was trying the method to check the snapshot below. Does each entry mean a run? What does the response contain? Explain other columns that are seen. Okay, so let me do some investigation. So this is an investigation. I'm asking something and I give it some context, and then okay, so what does it say? Let's check. So request, the question you asked your AI agent. So what is the square root? So this was my original prompt. Request response. Raw JSON data containing the full conversation contains the AI response, tool calls, and execution results. Okay. Okay, so there would be some way to capture this JSON, right? There would be message. Okay, there's a bunch of things, bunch of information. So it says it contains the AI's response, tool calls, and execution results. The snippet shows tool execution details and the calculated result. Tokens, number of tokens, words, or pieces used in the conversation. So 834 tokens. This includes your question, AI's reasoning, code generation, and response. Right? Consider that the chunks of words, right? For example, roughly 1, 2, 3, 4, 5, 6. 6 tokens we can say, although it's never that. It's not always that a single word is a token. There's a chunking strategy. Okay, but consider it's like 6 to 7 tokens in the question, then the tokens which will be there in the AI's response, and the tokens which will be captured by reasoning, code generation, everything is a token. So token in, token out. Then execution time. So it's saying that less than 2 seconds, which is 1.659 seconds to write code, execute, and respond. Okay, and your request time, when did you request, of course, and state is basically whether the request succeeded or failed, right? Okay, yeah, and each entry is like one complete agent interaction. Right now you have 2 entries because we ran the same question twice. One was the basic test and one was the ML flow wrapped version. Yeah. So I think this is what is possible through method 2, which is basically going through experiments. Although AI has a third method also for me, and that third method is programmatically accessing traces. So if I add this code in a new cell, so let's go here and let's, through my workspace, I get to build my notebook. And all right. All right. So I want to mm, 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 mm. Hold on. So where is ML flow coming into picture? Okay, chalo, let's do one thing. Let's after this, let me paste this and let me execute this. Let's see what it gives. The expectation is that it gives the same thing via code, so I can programmatically access. Let's see. Saying, all right, so I get into an issue. It says attribute error, str object has no attribute info. So trace.info. For trace and traces, traces is mlflow.search traces. So there is an issue. Diagnose error. Let's diagnose error. So again, I got a chance to use assistant. Your code assumes that, let's see, what does it say? Your code assumes that each trace returned by mlflow.search traces is an object with an info attribute, but it is actually a string. You should print the trace directly. Okay, let's bring that code and execute. Is that what we expect? I don't understand. So I think I need to explain to AI what's happening. But here, I would like to revert, right? So is there a way? How do you go back in history, or I say Control Z? Mm, hmm. Okay. I tried step 3 and got into an issue. then I can say string got into an issue. I used Genie assistant. Okay. I use assistant to diagnose the issue, suggested the change, check the image. I accepted change and the code. I see result, check second image. So I need to capture the second image, which is, I come here, I can see this. I'll take this and mention that this is what I'm getting. I'll copy this, come back here. Is this what's expected? I don't think so. Expecting some data here. Yes, I was expecting those values, which I was saying in method 2. This method 3, it is expected to give. It asked for some change, it did it. So it said that you're right, this isn't. Now this is what um, relying on intuition and experiment, it gave something. Yeah? We just saw that it gave some fix for the issue. It said that your code assumes. So let's come back. And the actual code was this. Where did it go? Okay, so yeah, so we had a piece of code. We basically gave that code, right? And that code was given by Claude only. So I'll just put that code again here. And it says, if I execute this, it gives an error. str object has no attribute info. So this trace.info doesn't exist. So I give this code, and it says that code assumes that each trace returned by mlflow.search traces is an object with an info attribute, but it is actually a string. You should print the trace directly. So it gives me a modified code. I accept the code and I execute it, and I get this. And this is what I feel is not the right thing. And I gave the same understanding, same context to AI. So it's saying, yeah, trace ID, state, request, response. Why this happened? The programmatic access to traces can be tricky in notebooks. The mlflow.search traces might not be finding your traces, or the data format might be different. Better approach, stick with the automatic trace display. You already saw the MLflow trace UI that appeared after your agent ran. That's the most reliable way. So the option with the first one, which we saw, it says it's the most reliable because it's there in front of you. So we can go here, and this what comes on MLflow trace UI, this entire thing, right? So it says it is the most reliable one, which is fine since it didn't work in one shot and it is getting into issues, which means it's not tested well, or maybe it's not the best way, right? So if it was useful and people were using it, it would not be this difficult, but we can come back to it later. It's not that important. It was just a investigative question. right? Or it says that there is a simpler approach. It says, let's see if we can try this. It gave something, but I'll come here, come down, and something is there. Let's see. Okay, it says invalid attribute column T for order by. Okay. Nonetheless, so we will just stick with simple Databricks, which is a simple one which Databricks offers natively, which is option 1. Okay, so I'll mention that and I'll mention that basically I tried that code and it failed again, which is this, right? Some error message. So instead of going into that, what I'll say, what I'm saying is, let's use this because it's already working. That's an alternative and it's not a challenge right now. It's not a road blocker. So we will skip this. So I'll just mention that to AI, mention that to Claude for its information. That hey, the code in option 2 didn't work. Given that Databricks already provides an easy to see and easy to see UI for traces. Let's park this for now. What say? So I'm giving continuous feedback to AI as I am doing all this. Okay, so it is saying useful, reliable, get back to understanding of the core agent code. That's where the real learning value is. That's correct. So we should get back to the understanding of code which we were doing, correct? So no worries, slow. So let's just quickly get to the context. We were here, MLflow, OpenAI, Autolog, right? So let's move on. Next section, connecting to the AI model. Next section is connecting to the AI model where we were here. So this is where what we're doing is it creates a connection to your Databricks model serving endpoints. Serving endpoints, okay, uses OpenAI compatible API format, even though you're using Llama. Okay. Workspace client dot serving endpoints dot get OpenAI client. It's creating OpenAI client. So are we using that? Yeah. So if I'm calling OpenAI, I didn't get this. Okay, got it. So it is AI is Claude is clearly saying that. So when I am talking about this line of code, it creates a connection to your Databricks model serving endpoints. Where are your model serving endpoints? We have checked them, serving here. Okay. And I think what we are connecting to is MetaLlama 70B instruct. I think, yeah, this one. Yes, 70p instruct. This is what it is connecting to. So this is endpoint, and that's what we come back to that piece of code. Creates a connection to your Databricks model serving endpoint. Okay, uses OpenAI compatible AI format, API format, OpenAI compatible API format. The client will send your question to LLM you selected earlier. Why this approach? Databricks standardizes on OpenAI's API format for consistency. So there need to be some format, right? So it enforces that whichever LLM I talk to, but the format which will be applicable will be OpenAI's API format. That's what it standardizes, and works with any model, Claude, Llama, GPT, whatever, through the same interface, and simplifies switching between different models. Makes sense. And the impact of execution, it sets up the communication channel to your AI model. Your agent can now send prompts and receive responses. No visible output, but the connection is established. This is the bridge between your code and the actual AI brain. Ready for the next piece? Yes, let's proceed. Okay, so next piece of code is Databricks function client. Okay, so loading Databricks built-in tools, a stateless Python code interpreter tool. Okay, so that's what gets loaded. UC function toolkit, function name system.ai .python exec for tool inbuilt tools. Okay, something. Okay, what this does, line 1 and 2, creates a connection, creates a client to access Databricks built-in AI tools. Yes, Databricks function client connects to Databricks tool registry. Okay. Lines 3 to 5 loads the Python code execution tool. So Python code execution tool, which is this one, that gets loaded. UC function, UC function toolkit formats this tool for AI agent use. Okay, so it does some sort of formatting, this tool for the use by AI agent, and dot tools converts it to the format your AI model accepts. Okay, then removes a compatibility setting. Okay, there's something happening, deletes the strict parameter that some models don't support. Okay, ensures broad compatibility across different AI models. Okay, some way it is helping to, first of all, this is the stateless, that's what it says, like stateless Python interpreter, right? Stateless Python code interpreter. And that's what it is, built-in Databricks built-in Python interpreter that needs to be called. So Databricks function tool function client, it gives access to Databricks tool registry. Right? And then UC function client, it basically formats whatever is the tool. This tool gets formatted for AI model use, and the tools converts it to the format your AI model expects. Okay, then removes a compatibility setting, deletes the strict parameter that some models don't support. Okay, ensure broad compatibility across different AI models. Okay, I think fair enough. We can believe what AI says or AI writes. So here we go again in this, and we can now read that code again with a better understanding. So, all right, so we get these all the dependencies imported. Then here we do the automatic logging. The call conversation is basically continuous logging happening. Then basically from serving endpoints, I basically enforce the OpenAI API format, right? And this basically creates a client. And then I'm doing the function call. Basically, I'm loading Databricks built-in tools. So I'm getting access to the tool registry. And then this is the tool I'm using, which is Databricks internal Python code interpreter. which is then a format is applied, then some other format is applied, which the AI model understands. Then some sort of compatibility check is happening. So all those things is happening. All right. So okay, that part is fine. Then there is a call tool is happening. So so basically, let's come back. So let's say, why does it matter? This is what transforms your AI from text generator to problem solver, right? Because it has some tools to work upon. The AI can now write Python code, execute calculations, create visualizations, process data. The AI can now write Python code, yes, execute calculations, create visualizations, process data. Great. Impact of execution. Your agent now has hands. It can do things, not just talk about them. The built-in tools variable contains the tool definition your AI will use. This is the key piece that enables the multi-step reasoning you saw earlier. Ready for the next section? Yes. Let's proceed. So my next section, just for quick understanding, is going to be this call tool. Let's see. What do we have here? So it's a function call, tool name parameters. Tool name is this, return. So, so some sort of tool call it is, right? So it acts as a dispatcher. When the AI decides to use a tool, this function actually executes it. Correct. Correct. Defines the function, takes tool name and parameters, checks if the requested tool is the Python executor. If yes, creates a new client and executes the Python code. If the tool is unknown, throws an error. Notice the tool name format change. System underscore underscore AI underscore underscore Python exec versus dots. This handles the name formatting difference between how tools are registered versus how they are called. Okay. Is this registered or this one is called? Okay, there is a difference. When they are registered, there's underscore underscore, and when they're called, there is dot dot. The AI can request tool usage, but sometimes need to actually run the tool. This provides a bridge between AI intent and actual execution, allows for AI handling if unknown tools are requested. Okay. Call later when your agent needs to run Python code. Okay. When the agent wants to run Python code, this gets called. Call the tool. This is the hands of your agent. When the AI says, I need to calculate something, this function does the actual work. Right. That's true. So let's look at the code now again. It will look more familiar. So it's checking that if the tool name, right? This is the tool name. And what do we see here is, if we see this one function name dot dot. So when it is being called, it is dot dot. Right? And when it is registered, I think it is underscore underscore. So there's a difference between the name at register when it is registered versus the name when it is getting called for. So something to keep in mind. And if the tool is not there, it will throw a error. All right. So, okay. So that's the piece. Fairly simple. Okay. I would say let's move or let's proceed. Let's proceed. Now this is going to go into the last function, which is also the larger one. Let's quickly check that. This one, run agent, and bunch of things is happening. So let's go back and check. So we are here. This is the brain of your entire agent. That's what it says. Let me break it down into digestible pieces. Function purpose takes your question, sends it to the AI, handles tool execution if needed, returns the complete conversation. Okay, so let's look at it. Line 4 creates an empty list to store the conversation. Okay. The initial AI call, line 5 to 9. Let's get to. So I'm here. So what it says, it takes a prompt, which means the user question or message. Send a user prompt to the LLM and return a list of LLM response messages. The LLM is allowed to call the code interpreter tool if needed to respond to the user. Okay. Result messages. Okay, so this result messages, it's a list. It will store the conversation. Let's see. Then response, OpenAI client chat completions create because it enforces OpenAI format. This model is going to be LLM endpoint. It was, what was it storing? It was storing the instruct, right? Llama instruct 70p. And then messages role user content prompt. Now what is this? When we come here, when we, yeah. So what's happening is 5 to 9, which is this one. Right? So it's an initial AI call. So the prompt goes to the selected LLM, includes the available tools. So the AI knows it, can use them. So built-in tools. So these are the built-in tools which are included. These are the tools which AI can use and gets the AI response. So this is where the response is stored. Okay. And AI basically responds with the decision to use the tool, right? Okay. And then line 10, 11 processes the AI's first response, extracts the message from the response, adds it to the conversation history, extracts the message from the response, adds it to the conversation, yeah, history. This is where the AI thinks and decides if it needs tools. Should I continue with the tool execution part? I would say, I would say, give me try this for more tracing of variables to get better understanding of code execution. I'm asking that you put more prints, so that I can understand it more properly. So I'd say modify this code for more tracing of variables to get better understanding of code execution. Here's the modified version with detailed tracing. Yeah, see, it's going to give detailed tracing. Maybe I can use it later. Yeah, it's basically putting up a lot of things, right? Yeah. So I can actually use it and replace it here. I'll come back. This definition, if I put it like this, it's more detailed, it's more verbose, but it's more useful because I can read each and everything. It is printing as it is doing things, right? Sending, responding, message content, tool calls requested. So there's a bunch of additional information, what goes into the function. So it is all blue. Step 1 to 2, AI processing and decision making. This one. Sending prompt, AI responding. Yeah. So this is input processing. This is sending prompt to AI. Role user content is the prompt. All the tools are passed. Then AI responded processing, response dot choices, message. Okay. Response is stored. Content. Then tool call execution details. Okay. Okay, tool arguments, call tool, tool result, role content, result value, function name, call ID. Yeah. Okay. It's pretty good. So what I'll do is I'll execute this. And then when I say, it is the capital of is the capital of United States. So here the AI should decide that I should not use, correct? Okay, endpoint. Let's go ahead and execute this. This should actually load the LLM endpoint. Basically, I'm executing it again. Maybe it got disconnected. Let it execute. It gave a bunch of things. You see, the model which got called is Claude Sonnet, which interestingly, it switches. So I want to check this here. It should. Here it is saying Sonnet then. Sonnet and instruct. Okay. It's printing Sonnet here. What is AI? Recall is not happening. Input. Permission denied. I don't want to call that, no. Earlier I called a different. It was a different one when we called earlier. Let's check. It was a different one. Let's check. It was not Claude Sonnet. It was Llama Instruct. Let me check. Mm. 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 Oh, no, it was Sonnet only. Okay. Okay. So what I can do is, why should I even give it a choice? So Let me then take it off. Yeah. It has only one choice. Let's see. Again, permission was denied because I think we are in free edition. Yeah. See, we're Metalama. So it is basically giving you a bunch of information and there's no tool call happening. So it decided not to call the tool. Correct. So here, let's check. It would be Llama. And now if I collect the logs and define all this thing, and here now we again know what is AI. Through ML flow, should be tracking and all those things. Using model this. Availability tools, one tool. I think that is Python code interpreter. Right. AI responded, processing message, messaging content. Tool call requested 0. Yeah, this is useful. Tool was not called. No tools needed. AI answered directly. Final returning one message, which is about what is AI and all those things. Right? It very nicely shows, right? And that's why we wanted to do more logging. We wanted to investigate. We wanted to understand, spend more time understanding this piece of code. So even if I've not written, I need to take charge of this, right? So I keep asking and I ask it to log, give value of each variable. So input, model, one tool is available. Prompt was sending, we're sending the prompt. AI responded, processing the message. There's the message content. Then tool called 0. No tool was needed. AI answered directly. This is a very important step of Agentic AI. So Agentic AI decided, I won't call that, right? So finally return one message. All this gets returned.